Okay, thank you for the time. Uh, Let me deliver our research entitled Study of Thermal Performance of Natural Refrigerant for Ice Machine. Let's let me start my presentation about Indonesian government commitment in the energy sector via Kebijakan Energi Nasional and Rencana Umum Energi Nasional. So this is our quantitative data of the domestic energy demand. And in the prediction, the domestic energy demand will increase as the increase of number of family. And this is a challenge for application energy efficient, especially for domestic, uh, for making ice process. And this is one of the main indicator of energy conservation and sustainability. Let's start with ice. Ice now widely used for drink, food preservation, and cooling, which support all industry sector and variety of other commercial and home function, particularly in a tropical nation. In addition to direct consumption, ice cube present dominate in the ice market with dimensions about 20 millimeters. This type of ice is becoming increasingly popular, and for the machine system in general, using Air 134A, which has rather high global warming potential value, about 1,300, to its fluorine component, and climate change will accelerate as a result. So, according to Kyoto and Montreal Protocol, the Air 290 resolve as the best candidate to replace Air 134A. And this is our experimental setup. Uh, the compressor, condenser, capillary tube, and the evaporator. As you see in here, the evaporator in here, there is a water from the source that flowing through the evaporator, which shaped in as a cube, small cube. It's about 50 cube mold, and in this surface of the cube will form the uh, ice layer. And now see result in discussion. In this figure on the left side, every minute we have collected data. The theoretical parameters of the system performance were then computed using equation 1, 2. The figure the left figure display the analysis display and Quebec 1.5 program and the pressure enthalpy thermodynamics study. And this for 5 cycles. This figure for 5 cycles of cube ice forming. And let's start with the um, energy absorbed in the evaporator as shown in figure 4. As the working time increased, the cooling load dropped somewhat as the temperature of ice water falls. You can see this is drop of the heat absorbed because of what? Because of the temperature of the water, the water source is decreased. Now let's see the figure on the left side. In this figure is the COP coefficient of performance. The coefficient of performance gradually increase as increase the cycles of the ice machine. This phenomenon is induced by the evaporator temperature and the temperature of the ice water. These are both growing cooler using the system called, and the figure on the right side depicts the ice quality generated through each ice making cycle. This is first cycle, second cycle, third cycle, fourth cycle, and fifth cycle. As the number of cycles rise, there is a visible improvement in ice cube cooling point with the level of thickness of water. And from our experiment, we can generate the conclusion is uh, we can conclude one, the suggested technology may be used for environmental sustainability by employing the natural refrigerant at 290. Based on the current operating circumstance, the best COP achievable is around 2.77, which occur during the fifth ice making cycle. As the number of cycles increase, the aesthetic attractiveness of the resultant ice cube improves. That's our presentation. Thank you very much.